Today, there's advanced in the form of verification technology. It's the only way to prove that a design is correct. The standard advances continue to make it better. Expert at the table, semiconductor engineer Lin sat down to discuss the advances in the form of verification tools and methodologies with the Ashish Darbari, CEO of Axoim, and Jin Chang, the product management group director for the verification group at Cadence. Sean Safapur as executive director of R&D and Synopsys, and Jeremy Lovett, the principal engineer for the digital verification technology at Siemens CD. What follows excerpt from that discussion. Yeah, I see. We hear about advanced informal verification when there is a startup, but less so when the development is happening within the large EDA companies. What technological advances are being made here? Love it. There's exponential problems, so there is plenty of the headroom to improve the performance. There have been points where there have been discontinuities and new algorithms that have come along. But even without that, from release to release, from year to year, and so you see the tools get 25% faster, twice as fast. We see exponential performance gains. Of course, the designs keeps getting bigger, and it is a very difficult game of chess you're playing here. But there is a significant improvement in the performance tools. And there is something to sometimes do the tuning to the heuristics and applying the machine learning to figure out our parameter settings or better areas of investigation is due in part to the use of cloud, where there are extra computing sources available, and that allows you to do many things in parallel. And we are beginning to see some improvement from the application of the LLMs, but there may be the more in future than it as tools today. And for a startup to make a lot of noise, we haven't had a startup in the pure former verification domain for a while. The first using the former is seeing a lot of innovation, a lot of impact that the expansion in types of problems that they can solve, and the profile of the what uses for verification has changed dramatically. A lot of these companies are showing the power verification can add a lot of values in terms of the finding bugs or doing sign-off. I want to talk about SAT competition. SAT servers one of the main foundation server for formal verification, and the SAT competition has been around about 20 years. So in a while the new SAT server comes up. There was chaff and chaff. This is groundbreaking, and people said this is probably as good as this get for NP complete problems, and the mini set comes up, and the things that happens, and then for a while, even SAT expert would say things quieted down. But if you go back 5 years, cassette and mapper set, and a lot of new servers coming. If you look at the set computation and the recent result, they're just blowing the previous year's results out of the water. There is still a lot of innovation happening from the fundamental level of the service all the way up the application chain. There's still a lot of innovation happening, even at this basic level. Some of the latest data is showing how AI can help improve a lot of these SAT server algorithms. It's pretty exciting, and there is a lot of movement for people a little bit outside of community. It's hard to see, but I think it's a very exciting time to be in the area. Jasper is owned by Cadence, is still very successful in the market. Everyone's efforts are keeping the R&D team on their toes in developing new technologies. A lot of those are behind the scenes at their engine level. There's improvement that users may not see. So our idea is ideal goal is not to give them a lot of notes for them to tune, but rather to give them the orchestration so that it's easier for them to use former. That has been the biggest challenge over the year: technology improvement, SSH servers and cloud, distributed computing. All of those things are happening. A lot of implemented that has gone into from all companies just to stay on the par or ahead of the competition. The worry is all of the EDA companies are producing wonderful tools which have been made people like us look bright in the field. A lot of work that has been done recently is in SAT servers. As the users of former tools, we see them making a big difference in the proof convergence rate. But let me take a step back and describe 5 key areas that define former uses. The first one is property generation. Who writes the properties and how good are these? They are not going to be invented in the ether unless they are standard protocol. If they are trying to specification, and the elephant in a room question is, how do you take complex, large specifications and turn them into meaningful properties? And unless you've done, you can actually solve the functional verification problem with former. Although a lot of app-driven former continues to be used, is making a big difference. Unless we start to adopt the former in its function space by making better connections with the specifications and making proper generation faster, better and more efficient, and we can't actually make that of much of the difference with former. With efficiency comes another associated challenges, which is the constraint of refinement and making sure the constraint are captured correctly and we have the model efficiently. Once these two things are done, as in assertions and written assumptions are adequately modeled for correctness and efficiency. And then if they failed, you've added third challenges, which is debug. A lot of things have been happening in the tools, and they wanted to talk about the next elephant in the room, which is proof convergence. How do we make those things better and faster? Design complexity keeps increasing the several-fold, so there is always a catch-up to do. And then I sign off the coverage and do how do you holistically address all of the last bits of the story to make sure that everything that was formally verified was actually done properly. Then the bugs were left in the silicon and so on. From a user point of view, and this shift is moving forward customization of the solution layers. This is where we are doing a lot of work, as well as customers now seeing a former a way to where they were perceiving it before. As you're talking about RISC-V, for example, there is a lot of custom solutions work that we've done. We are finding benefits in this. 10 years ago, if you went to somebody that said you could verify an in-order processor or out-of-order processor exhaustively with former, they would laugh at you. And there was not something they could think of, but today we can do this. It's a combination of servers and application engineers writing the properties effectively. A lot of former is quietly making all the difference in the various aspects of verification. I've only talked about the functional, but there's other aspect where it's making a huge impact. Jeremy, my first answer was about the performance of the engines, which definitely have been increasing exponentially. But Ashish brings up an excellent point about the improved use models and how easily the tools allow users to access this power. We haven't seen a continual innovation there on the tool side, making it easier for users to specify what they want. Communicating the back about the tool needs and improving the overall flow so the tools can be used much more effectively by a broader range of customers and knowledge levels. John, if I look at the past 20 years, What are some of the major changes along the way that have been really promoted former to broader user base? The standardization of the SystemVerilog Assertions was a key part of it, and the proliferation of the former as a technology in different domains. The app-specific solutions created around tools helped in finding all the different use cases that former can be used maybe without expertise. That was a great venture which broadened the former application. Another of it comes the mind to former sign-off. Before then, former was always seen a debug tools. If you can't sign off a block, it comes nice to have. Maybe they must have the ones you could do sign off and bounded sign off when you have a methodology that really helps people see former in a more serious light. You can really deploy the flow lately with the machine learning infusion, the more lead gen AI. A lot of things that are happening are major milestones that are promoted former to being regarded as part of the validation flow. There is a lot less mission reselling that we have to do these days. All the other things behind the scenes that the R&D teams are working on, standardization and methodology contributed to former. It's really a mainstream tool every company is using these days. And let's see, we hear a lot about advancements in data centers, new technologies like CLX and HBM. Former has always been limited by the amount of memory that it needs and an amount of compute that it needs. Theoretically, now we have the infinite memory and infinite compute. How much is that helping former? Robert, these new architectures reliably give you a linear speed, but the problems are exponential. At least MP hard. We're taking that, but I would still say most of the advances are being driven by the improvement in the SAT servers. Those are getting exponentially better. Improvement in the engineering related to the algorithms we run and how we orchestrate them also are gaining exponentially better, increased compute power. We are taking that, but it will a linear speed up and sometimes a super linear if it enables you to do more things at once. But the real performance improvement are still coming at the fundamental SAT server level, at the algorithm level, not from the increased availability of the resource. Double, apart from the SAT server efficiency, how you model things make a significant difference with the abstraction. I have very good examples from recent work, which we presented at DVCon India of a RISC-V processor. It had a 5 or 6 stage deep pipelining running on a machine with 1.5 terabytes of RAM of 69 cores. We got a bounded proof at 10,331 cranks, trying to prove that one instance of add instruction can be sent in a pipe and can actually execute it correctly. Never mind the entire space of instruction, just one add instruction. We then went through the process of the breaking down and bringing in coverage analysis and abstraction engines. We were then able to prove the same property in about 100 seconds with bound of 18. The only reason we couldn't prove it earlier was because there was a live log in the processor. We went about finding it, and because it's MP hard problems, and it won't go, we are trying to verify our synthesis of operands and all the cases. If any one of these cases encounters a pump, and proof is solved, you can throw the biggest machines at it, but you can't actually make a difference. People who have been using the former understand that. Would I be able to get the same result on a smaller machine? In this case, when we did through the same benches on an 18 cores machine with 128 gigabytes of RAM, and we also get the proof exactly it took a little bit longer. Compute will make a difference, but it's asymptotic static, and throwing more compute at the problems wouldn't make a significant difference unless we understand what is being verified and how it is being modeled. Pool. If we look at from the user's pool, as if we look at it from the user's problem's perspective, Assertions talking about a problem with a single property that's hard to prove. There's always that case. But what we are seeing is that a vast size of the problem and the sheer numbers of properties that they're trying to work on is orders of magnitude bigger than a previous generation. It's not uncommon to hear from our customers that in a former property verification setup, not connectivity or coverage or anything like that. They have hundreds of thousands, if not millions, of properties that may need to prove. In this setup, compute make a really big difference. If you hundreds of cores available, thousands of cores available, big memory machines, there's a lot that you can do. While proving a property can always be hard, one of the challenges that we find ourselves having to solve is one of the management. You have hundreds of thousands of properties, you have hundreds of cores at your disposal. Even when you're running at this nightly for regulations all a week or over a week, there is a property that have not gotten enough time for any single engines to work on it. You have to innovate because in the past you wouldn't have problems that are as broad as they are now. The sheer volume of what our customers brings to us has become a major challenge. The machine availability is there, but what we need to do on our orchestration side and a smart development to really plays a critical role. And customers do come to us and ask, what if I give you 10,000 cores? What if I give you 100,000 cores for a few hours? Could we crack this? It is opening up this massively parallel domain. This is great, and the problems are getting harder. The compute is available. That allows us to tackle this new set of problems. John? From a tool perspective, we definitely want to leverage parallelization and leverage all the compute, but the reality is the customers don't have unlimited compute. We are still working with the constraint that there's only so much compute we can give you, and we are competing with the simulation and all the other tools. There's a real-life limitation, but on the technology side, there are a lot of advancements that are taking advantage of what we can do to parallelize jobs, orchestrate it in a way that is most efficient, and leveraging previous result. All of those improvements are from the tool perspective, but I wish we had unlimited compute. Okay, today today I read this article, Advances Formal Verification Technology, the Brian Barry's article. Thank you for your time. See you next time.